Hello friends, in this video I'm going to solve a very interesting problem of on gamma and beta function. Okay, so here we can see two questions, actually same question asked in different way. Okay, either it is it may be asked to prove this is equal to this, or question may be asked this way, that express this in the form of beta and gamma function. Okay, beta and gamma function. I forgot to write the function word, beta and gamma function. And if you are pursuing BSc in physics under Dibrugarh University, you must get these two questions in previous year's question papers. In 2023 this was asked in this way, and in 2025 same question was asked in this way, right? In third semester of CBCS course. Okay, so now here before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel and inspire me to create new contents for you, right? So now let's start. So now we need to express this in the form of gamma and beta function. How to express this? We know the gamma function, sorry, beta of m and n is defined as integration from 0 to 1 x to the power m minus 1 minus x whole to the power n minus 1 dx. We know that, right? Now let us consider that x is equal to sine square theta. Let us consider x is equal to sine square theta. So if x is equal to sine square theta, if we differentiate both sides, dx by d theta with respect to theta, if you differentiate, then 2 sine theta and derivative of sine theta again cos theta, right? This is function of function. We're gonna differentiate it considering that sine is sine theta whole square, like this, sine theta whole square, and if you differentiate it with respect to theta, then it should give 2 into sine theta whole to the power 2 minus 1, and again it is function of theta, so function of function. So ddx of dd theta of sine theta, that's gonna cos theta, that's gonna give you cos theta, which is equal to this, right? Hope you have understood this differentiation, right? So now you see, so we can write this in this way, dx is equal to 2 sine theta cos theta into d theta, right? We can write this way. Okay, so now you see, then we can say that 1 minus x square, sorry, 1 minus not x square, 1 minus x, that's going to be 1 minus sine square theta, and 1 minus sine square theta is nothing but cos square theta, right? That is cos square theta. So we know these things, right? So therefore if it is 1, then from equation number 1, what we can write here, you see, beta of mn, here we can write, and one more thing, important thing. So here you see, if x is equal to sine square theta, then when theta is equal to 0, then sine square theta will be also 0. Sine square of 0, that's going to be 0, sine 0 0, right? So then x going to be equal to 0, right? And when theta is pi by 2, theta is pi by 2, then x is equal to sine square pi by 2, and sine pi by 2 is 1 square, that's going to be 1. So in that case x is equal to 1, right? X is equal to 1. So when we replace this x by sine, then we can replace these intervals by 0 and pi by 2, right? So integration from 0 and pi by 2, and instead of x we're gonna write sine square theta. So here we have m to the x to the power m minus n. So here m minus, not n, m minus 1. Then 1 minus x is nothing but 1 minus x, which is nothing but cos square theta. So we're going to replace this 1 minus x is cos square theta. So this is replaced by cos square theta and whole to the power n minus 1, and dx will be replaced by 2 sin theta cos theta d theta. 2 sin theta cos theta d theta, right? So now if you simplify this part, then you should get this, right? You should get sine to the power, twice m minus 2, right? We know that a to the power m whole to the power n is a to the power m into n. If you apply that, then you should get this. Similarly, if you apply this one here also, then 2 into n minus 1, that's going to give you cos theta whole to the power twice n minus 2, right? Hope you have understood this. And this 2 can be written outside the integral as it is constant, so we can write this 2 here. So 2 is written outside the integral, and if you multiply this sin theta with this, then here power is 1. So here we're going to have minus 2 plus 1, that is 2m minus 1. Similarly, if you multiply this cos theta with this, then here also power 1, so minus 2 plus 1, then it's going to give you 2n minus 1 and d theta here, right? Hope you have understood this. Okay, right. Now you see, as we are to express this in the form of gamma and beta function, so we're going to compare this power with p and this twice n minus 1 with q, right? Then what we're going to have, so, and one more thing, here you see this can be written this way. Just give me a second. So let me write it on the left hand side, is equal to this 2 on this side, it's going to be half, right? Half of beta mn. Okay, so we can write this way. Okay, now you see, let me split the screen into 2 parts. Okay, so now you can see, we can compare that p is equal to 2m minus 1 and q is equal to twice n minus 1. So from here, if you simplify this, p plus 1 is equal to twice m, which is going to give you m is equal to p plus 1 by 2. And similarly here we're going to have n is equal to q plus 1 by 2, right? So that's why, therefore, we can write, let me write this one. So therefore, if you replace these 2 by p and q, what you're going to have on the left hand side? You see, let me copy the left hand side, just give me a second. So here you see, this is the left hand side. Okay, if we replace this by p, okay, then here you see, so let me replace this by p and this one by q. Okay, so then here on the right hand side you can see, just give me a second. Okay, let me rearrange these things. Okay, just so it can be written this way without using these brackets. Okay, sin to the power p theta cos to the power q theta. Let me write without this brackets. Okay, so we can write this way. Okay, so now on the right hand side of this, you can see here, just give me a second. Here now m and n, these two should be replaced by these two values. M will be replaced by this and n will be replaced by this, right? So that will be done in the right hand side. Okay, So hope you have understood this. So on the right hand side is equal to, now half of beta, instead of m we're going to write p plus, so here it is beta, p plus 1 by 2, and n is replaced by this, n is replaced by q plus 1 by 2. So here you see, now this is in this in the form of beta function. So it is the form of beta function, right? Now how to write this in gamma function, in the form of gamma function. Now let me copy this last step and let me go to next slide. So here you see, this is the next slide, and here is the last step. Let me write it properly. So we know that relation between the beta function and gamma function, this can be written this way, that gamma of m, gamma function of m, gamma of n divided by gamma function of m plus n, right? M plus n. Now we're going to replace the m by p plus 1 by 2, and n will be replaced by q plus 1 by 2, where, as I have already explained here, you see, okay, these are the values of m and n. So we're going to put these values here. So what we're going to have, beta of, so here we have, instead of m p plus 1 by 2, right? P plus 1 by 2, and comma q plus 1 by 2 is equal to gamma function of instead of m, p plus 1 by 2, and gamma of instead of n we can write q plus 1 by 2, okay? Then gamma function of p plus 1 by 2, m plus n means p plus 1 by 2 plus q plus 1 by 2, and if you take LCM, that's going to be equal to p plus q plus 2 divided by 2, right? So that will be the result, okay? So now let's multiply half on both sides. So half and beta of this, here you see, let me write this one here. So here let's multiply half on both sides of this above equation, then here half into this, let me make it small, it's taking large space, okay? So just give me a second. Okay, sorry, just give me a second. Okay, just wait. Okay, now it's fine. Then so this is what we have got, right? So now here you see, let me write on this side. So now you see, this is nothing but this one, right? So we can replace this by this, and so we will get, therefore we will get what we're going to have on the left hand side. We're going to get this, right? This is suppose equation number 2. Let me write equation number 2. So from 2 we can replace this by this value, and on the right hand side what we have got half, then gamma function of p plus 1 by 2, then gamma of q plus 1 by 2, right? Q plus 1 by 2 divided by gamma function of p plus q plus 2 divided by 2. So this is in the form of gamma function, right? So so let me take this is 3. So from 2 and 3 we have got this. So this is the form of gamma function, right? Hope you have understood this. So thank you for watching. See you in the next video. Bye bye.